Hi everyone, so I'm going to actually go to full screen. A few of you asked me to go over a few questions from the review since I won't be in class tomorrow, and I appreciate those of you that came to see me today. So I'm looking at question number 5 from the Geometry Honors Review Packet, and it says, two circles intersect and have a common chord. So if it's common and it goes through the circle, that means that they share it. So I had two circles that have a common chord. That means those circles have to overlap, okay? So I had something, oops, let me grab my pen. It's something that looks like this. I have two circles, and we got to draw a really good picture. Sorry, my circles aren't perfect. And if they have a common chord, I want you to think about that. I could, like if I draw the chord going this way, that's not common. There's a little piece that's in common, but that's not a common chord. So the common chord really needed to be drawn. Let me pick black. Needed to be drawn right here. If you see, that goes in both circles. And it said that that chord was 120 centimeters. Okay, I'm going to get that little piece out of the way because it's going to drive me nuts. Okay, the radii of the circles are 68 and 75. Now, this is where it gets tricky. Remember, we've talked about it. Put your centers in. If I draw my radius going towards the black line perpendicular, it's not going to help me because I'm going to have overlapping radiuses. Remember I said it's best to draw your radiuses to the circle, like that. So that radius I know is 68, and this one's a little bit longer, which is 75. Okay, so I realized that if I connected the radii like that these would be perpendicular, okay? So that line would be perpendicular to that. And I knew that I was looking for this and for this together. So I really wanted x plus y because that would give me the distance. I'll call this circle A and this circle B. All right, so I've got some work to do, except for the fact that they told me that the chord was 120. So the way I drew it, this side of the triangle is going through it at the midpoint, so this then would be 60. All right, so I can find x and y. I have two right triangles, so I can do x squared plus 60 squared equals 68 squared, and then I can do y squared plus 60 squared equals 75 squared. All right, so let's do that. So we've got, let's see, we've got 60 squared, which is 3,600. Didn't use my calculator because I know that 6 squared is 36. And then we've got 68 squared, which is 4624. So x squared plus, and then I subtract the 3,600, gives me 1024. So I've got x squared equals 1024. So then x equals, I'm going to take the square root of that. Hold on, I'm having trouble. That gave me 32. Okay, so x was 32. So I've got part of it, so I need the other part. So I'm going to do again, y squared plus 3,600 equals, oops, I wrote 360, 75 squared, which is 5625. And this is just the arithmetic, so I know you guys can do this. Minus 3,600, which gave me 2025. Let me come up here so you can see it. Y squared equal 2025. And I take the square root of that, and I get 45. So y equals 45. Now remember, y equals plus or minus 45, but to the answer to this question, we'd only look at the positive. So that gives me 32 plus 45, which then is 77. All right, so that's number 5. Again, the drawing's the most important part. Number 11, again, another one that's the drawing. Now, this one, what I found when kids were coming to see me was that you were drawing them, you weren't really taking the advice I had been giving you about these circles. First of all, you do want to try and draw them to scale, okay? So I'm actually going to do that. I'm going to try to draw them, like if I have an 8 centimeter circle, it's actually smaller than my 12 centimeter circle, right? So I drew something like that. Okay, so I am going to make sure that I try and draw them somewhat to scale, and I'm going to make sure that I line up the centers so that they are even with each other. That's actually the part that everyone's been messing up, that I keep talking about. The reason I want to do that is because then if I'm making shapes outside them, I can see them a little bit more clearly. All right, so I know that this length right here is 8, and this length right here is 5, and this length right here is 12. So I know that the distance between them is 25, right? So I know that's 25. I'm going to put it offset like that. And I'm looking for the common internal tangent. I'm going to actually make it as neat as I can. So a common internal tangent touches both of them. So it's something like that. And actually, let me change the color of it to red so you can see it. Okay. Now, what you have to think about is that you know that if you draw this radius to the tangent, that you get a right angle. And if you draw a radius to a tangent here, you get a right angle. Okay, so I somehow want to figure out a way to get either a triangle or a rectangle involved here so that I can use that 25 to help me find the length of the red side. Okay, so because I'm looking for the distance from here to here. Okay. All right, so what I saw the hourglass, but I saw that if I extended this, I'd have a right triangle, okay? And I know that this is 12 because it's a radius, and I know that this is 12, and I know that this is 8. So that actually gives me this right triangle right here because I've created this like rectangle for myself using those auxiliary lines. So I have a right triangle with a side length of 20, a side length of 25. And if I find x, which is right here, then the opposite sides of the rectangles are congruent. Okay, so now some of you might see the Pythagorean triple, others may not, but 20 squared plus x squared equals 25 squared. It is a 3, 4, 5, right? So 3, 4, and 5. So 5 times 5 is 25. 4 times 5 is 20. So 3 times 5 gives me 15. So this is 15. So the length of the common internal tangent would be 15 as well. All right, I hope that helped on questions number 5 and 11. Let me know if you need any more. Thanks so much. Have a great day.